Now a few more properties. I'm not going to prove this. I encourage you to do it, but if not, well, just I don't know. Just remember these properties. So this is about 3 points with barycentric coordinates belonging to the same line, right? So if we have a line and there are 3 points, so then this happens even only if the determinant of the corresponding matrix of barycentric coordinates is 0. So notice that here, if we multiply every row of this matrix by the same number, the property that the determinant is 0, that does not change. It's still going to be 0. So which means that in order to verify this, we don't have to compute barycentric coordinates precisely. We can compute them up to proportionality. So we don't have to normalize them. Same for the next thing. So the equation of a line in barycentric coordinates is, well, it's just a linear equation, a homogeneous linear equation. But notice that here there are more. So K, L, and M are proportional to the signed distances from vertices A, B, and C to the line. Right, so if, say, I don't know, we have like A, B, C, A, B, C, and we have some line. So then signed distances are, so we take perpendiculars, we choose one of the two sides as positive, the other one is negative. And these are going to be K, L, and M. A very useful property. So this is one more property, and again, if you multiply a row or a column of this matrix by the same number, it doesn't affect that doesn't change the property of being 0. So it's just up to proportionality. And again, so this is about 3 lines meeting at one point. So this happens even only if the corresponding determinant is 0. Again, very, very useful. So if you need to prove anything where 3 lines meet at one point, then you can use barycentric coordinates. Okay, now this is the first exercise. It has 7 parts. They are probably of progressive difficulty. I'm going to do the first part for you, but I encourage you to pause the video now and to do it yourself. So derive barycentric coordinates of the centroid of the center of mass or the intersection point of the 3 medians of a triangle ABC. So what are the barycentric coordinates? And the next exercise is going to be the second one, so it's not very challenging either. So you will you can do it and submit online. The rest I encourage you to do. Well, at least 3 and 4 shouldn't be too hard, so this should be okay. From 5 till 7 are more challenging. I hope that you can do it, but if not, it's not a disaster. Okay, now let me do it. So let me explain how we can derive barycentric coordinates of the center of mass of a triangle. Well, first of all, you can, of course, recall that the center of mass, if you just take the usual coordinates, the Cartesian coordinates of the center of mass, then it is going to be simply the average values of the corresponding coordinates of the vertices, and which, if you think a little bit, converted to barycentric coordinates means that barycentric coordinates are just all equal, so 1/3, 1/3, 1/3. But let me explain how you can arrive at the same result using areas of triangles. Right? So where is the center of mass here? Let me write this. This is going to be A, this is going to be B, this is going to be C. So this is the middle of AB, this is the middle of BC, this is the middle of AC. Now this is our center of mass, the centroid. Okay, and recall that barycentric coordinates are proportional to areas of triangles. So let me of the corresponding triangles. So PAB, PAC, and PBC. So let me just show that all of them are equal. Right? So how can we do this? how can we show that all these triangles are equal? So first notice that this triangle has the same area as this triangle, right? Because BC is split into two halves, so these two triangles, they have the same base. Well, if I don't know, the point in the middle, let's say, let me denote it, I don't know, a prime. If this is a prime, then a prime equals c, and a prime c equals a prime b, right? So these two triangles, they have the same base and the same height from a perpendicular from a to bc, so they are equal, right? So because of the same reason, basically, the same reason, this triangle has the same area as this triangle. But then the complementary triangles, this one and this one, also have the same area. Well, and by the same logic, this triangle, PBC, also has the same area. So all the three areas are equal. So the areas of the triangle, the area of the triangle PAB is the same as the area of the triangle PBC is the same as the area of the triangle PAC. So which means that barycentric coordinates are all equal, so they are going to be 1/3, 1/3, 1/3. Or we can write it the same thing as 1:1:1. It's the same thing. Okay, so now you are going to go to the quiz. So here is the quiz. Let me show to you. Yeah, and notice that how the quiz is phrased. Basically, here you need to find barycentric coordinates of the center of the inscribed circle of a triangle. Come on, it's not being loaded. But the idea here is that if you don't know how to start, then there is an option for you, I don't know, that you can choose